Assalamualaikum everyone. Today we are from 4 Alpha. We'll be presenting about how to calculate the mass of Earth, Sun, and as well as other planets in the universe. So let's get started. This is the Sun, Moon, Earth, and all the planets in our solar system. So basically, calculating the mass of these objects seems impossible for humans. But with the help of physics theory, we can finally calculate the mass of this object.
Hello guys, today I want to show you about how to calculate the mass of Earth, Sun, and other planets in this big universe. It is very easy, you know. First of all, let us identify the basic formula to derive the formula for calculating the mass of other planets and also Sun, the big star that is located in the middle of Milky Way. First formula that we need to know is Newton's universal law of gravitation. This is the formula.
Let's see about Newton's universal law of gravitation.
Gravitational force is directly proportional to the product of mass of two bodies and is inversely proportional to the square of distance from the center of two bodies, which in turns gm m over r square.
Okay, second formula that we need to know is the formula for the centripetal force, the force which acts toward the direction to the center of planets. Okay, formula for the centripetal force is mv squared over r, where m is the object mass of orbiting object and v is the linear speed and r is the distance between the center of orbiting object to the center of planets.
In order to determine the mass of Earth, Sun, and other planets, we need to know the distance between the center of planets or Sun to the center of orbiting object. And also, one more information we need to know is the period of revolution of the orbiting object. Next, let's derive the formula mass to determine the mass of Sun and other planets. Firstly, let's equate Newton's universal law of gravitation with the centripetal force. The formula for Newton's universal law of gravitation is defined by F is equals to gm m over r squared. And the formula for centripetal force is defined by F is equals to mv squared over r. So, let's equate these two equations. Firstly, we are going to cancel out the common factor in both equations, which is the small m, which resembles the mass of the object. At this point, you will have this equation. We all know that to calculate velocity, we need to divide distance over time. But in this case, to calculate the velocity of an orbiting object, we need to use the circumference of its orbit as distance and the period of revolution of an orbiting object as the time. So, we can conclude that the formula to calculate the velocity of an orbiting object is defined by v is equals to 2 pi r over t. So, going back to the equation, we substitute this v with 2 pi r over t. After we get this formula, we are going to rearrange the m to be the subject of the formula. There we go. We have the formula to calculate mass of any planets and the Sun, which is m is equals to 4 pi squared r cubed over gt squared.
So, let's calculate the mass of Sun given the radius of orbit of Mars is 2.28 times 10 to the power of 11 meter and its orbital period is 687 days. The first step that we need is to change the days to seconds so that it will be in SI units. Secondly, we need to make sure all the value has the same significance figure. In this case, we use 3 significance figure. Lastly, we substitute the number in the equation. That's all.
Let's calculate mass of Earth. Given average distance between Earth and Moon is 3.844 times 10/8 meter. Period of Moon revolution is 27.3 days. First step, we need to change the days to seconds because calculating mass of Earth and Sun requires all unit in SI unit. Then substitute the numbers to the equation and there we get the mass of Earth.